Hi, my name is Lingwei Jiang, and I'm going to be discussing a part of our project for the software engineering project video report. For starters, we decided to use two datasets for this project. The DevGPT dataset, which is using the snapshot 2023-10-12, and also the LeetCode dataset that we generated ourselves by taking LeetCode questions and then passing it into the ChatGPT API. In order to answer research question one, which places a focus on whether or not the developers are going to get the same response if they were to prompt the same prompt with or without a setting, we decided to mostly answer research question one by using the DevGPT dataset. So due to the limitations of the ChatGPT API, we decided to only use one of the five data sets that's provided in the snapshot. We decided to use commit sharing because it consists, after manually reviewing it, it consists of mostly code responses. So we felt that that would be the most optimal for answering research question one. So what this code does is that it will iterate through the JSON file that we pass in. In this case, it's commit sharing, and it will check for it will add in all of the messages that only has one prompt and only has one response. It will add it onto this list called rest list. So in the end, the rest list, every index of this variable rest list is gonna have another list that consists of the prompt and the response. If we take a look at the commit sharing dataset, the first thing it will check the number of prompts. If it's equal to 2, that means that it's a one prompt message. And then it will go down to conversations, and then it will go down to the prompt and the answer. It will retrieve both of these and then store it inside rest list. So once rest list is once this function correctly gets all of the wrong prompt data from the dataset, we will use this resulting list and multiple functions that is used to solve research question one. Firstly, we have this function, which essentially it will first get the list of all one prompt messages, and then it will feed those prompts into the ChatGPT API with the setting. In this case, the setting that we set is very general because not all of the responses are guaranteed to be code only. So we want to make sure that if the response does not involve coding, we have a setting. And if the response include coding, we also have a setting for that. So essentially we pass in the response, we pass in the old prompt with the setting, and then we store the new prompt and the new response inside the CSV file. So on my side, I am tasked with prompts 80 to 148. And then once the ChatGPT process the new prompts, we will output it into output2.csv over here, which includes the original prompt, the original response, the new prompt, also the new response. Output2.csv only contains prompts 80 to 148 over here. Output 1 contains all of the previous ones. So once the outputs are generated, we will use compare response and also compare response text sim to basically generate similarity scores for these new responses. Basically compare the new response to the old response. I won't be discussing text sim version because Yuki is the one that will be discussing it. So for this compare response version, we are essentially comparing the differences. Comparing the old response with the new response by using ChatGPT API. So what's happening here is that first we will have a list that gets the two different outputs. So the resulting queries is gonna have all of the prompts, right? The old prompt, the new prompt, the old response and the new response. So it's a combination of both output 1 CSV and also output 2 CSV, which consists of all of the responses and the prompts. And then once it's done, we will go over all of the queries and then we will use get ChatGPT score, which is written here. So what get ChatGPT score does is that it will analyze the two responses. So it will analyze it will ask ChatGPT to analyze response 1 and also response 2. In this case, it's the new response, and then ask it to determine the similarity score of the two responses based on factors like structure and logic. We asked that ChatGPT only respond in numbers between 0 to 100, so it will not screw the resulting list. And then once ChatGPT gets the gives us a similarity score, we will return it. And then here we will write the results to the CSV. So this CSV is going to be named ChatGPT score. So essentially, what this CSV will contain is the original prompt and also the similarity score. Uh, Over here, we have the original prompt and also the ChatGPT score that ChatGPT has generated for each of the prompts. Um, so once we generate the ChatGPT score and everything else with the cosine similarity, Jacquard similarity, we store the results onto the software project datasheet, which will contain all of the information that we got, both all of the different scores over here. So this one will contain, it's a little bit messy, but it's gonna contain the prompt and also all of the scores. So we have the Jacquard similarity, cosine similarity, Euclidean distance, and the GPT similarity, which we will in turn use later to analyze essentially and try to answer research question 1. So for the most part, we decided to use the average score of all of these similarity scores, and we decided that for the GPT score, since the average was around 74%, we can say that there is a pretty high similarity between the old response and the new response, despite having the settings added in. So we don't really have a measure to basically measure the correctness of the response, and we cannot really automate that part. So the only real way that we can really conclude from this is through similarity score. But since the similarity scores are fairly close, we can say that uh, if the original response was completely off the mark or completely wrong, then it's safe to say that the new response is not going to be much better, and that developers will most likely have to come up with a different way of asking the same question or try to explain these questions better so that ChatGPT will be able to respond with a better answer.
Hi, my name is Yuki, and I'm going to continue on how we compare the old response and the new response that ChatGPT generated with and without setting. Since we don't know how ChatGPT calculates the similarity scores internally, we want some other ways to calculate the scores. What we decided to do is to use some algorithms that calculate text similarity, which Lynn already mentioned a little bit. We decided to use Jacquard, cosine, and Euclidean distance because they are the most commonly used algorithms out there. So first of all, the Jacquard similarity measures the similarity between texts by the number of common words between the two pieces of text over the total number of words. In other words, the score is calculated by the intersection divided by the union of the text, which is shown over here. And cosine similarity is different from J-card, in which it calculates the score based on the vectors. We represent the text using an n-dimensional vector space. Then we use this cosine similarity function that's available in the sklearn library. So for both J-card and cosine similarity, the score returned is between 0 and 1, with a higher score indicating a greater similarity between the two texts. And lastly, the Euclidean distance method calculates the similarity of texts based on the distance between the two texts. And the score returned is a little different, which is between 0 and an undisclosed positive number. And the small score indicates greater similarity between the two texts, since the distance is smaller. So our results show that J-card similarity score predominantly lean toward the lower end, with an average score of 0.26. But for cosine similarity, the score tend to lean toward 1, aligning with the scores Lin obtained from ChatGPT. And I think this is mainly caused by how the similarity scores are calculated differently for the two methods. So we know that J-card similarity computes the score by determining the intersection over union of the words in the two text samples. In our case, a large number of input prompts require ChatGPT to generate responses containing code blocks. And given the diverse structure in which code can be written, the union of words may be a lot larger than the intersection, and that's why the score is very low. As cosine similarity is better suited for approximated data and calculates the overall similarity, I think it works better with our case. And for Euclidean distance, the score tend to be toward the lower end, which is also consistent with our expectations based on the ChatGPT score and the cosine similarity score. But it is also important to emphasize that without any references indicating what score qualifies as good, our analysis only focuses on the distribution of scores. So from our observations, we can say that the score, the result we get from the similarity scores based on text similarity algorithms is consistent with what Lin previously concluded.
So for the last part of our project, phase 2, we have worked on gathering data on LeetCode for different questions, where we're attempting to see if we can use them to generate codes that LeetCode is able to accept. And by using different settings, for example, in this case, we have used the constraints like this. We want to see if by adding this extra setting, ChatGPT is able to generate code that is more efficient. So in order to do that, we have gathered in total 54 questions from LeetCode. For each of us, we did 8 easy questions, 6 medium questions, and 4 hard questions. That's how LeetCode categorizes its questions. Once we have obtained the question, we have in this specific format, so it can be processed by Python. We have written up a Python code that is going to be able to query ChatGPT using its API. And we also wrote a refile program to digest the files that we have written up. So we have a dictionary that we can work with. And this API, we have set it such that it will digest each question with the concept prompts that we have here and make sure all the outputs are in Python and code only. For the model, we use GPT 3.5 Turbo, which essentially is 3.5 that's slightly faster. And the entire experiment has ran for around 2 hours-ish to generate in total 108 codes that I have stored here. So then we have manually inputted the files into ChatGPT. Input the file into LeetCode and generate the following responses that for each of the question, we mark its difficulty, take out the acceptance rate from LeetCode. And if the code has been fully accepted by LeetCode, pass every single test, we give it a 1 on the pass rate. Otherwise, we give how many tests that has passed over the total tests that there is on LeetCode for that specific question. For those that has successfully passed, we have reported down the percentile of its efficiency in terms of runtime as well as memory in comparison with all other people's submission. If it didn't pass, then we would not be recording their percentiles as well as for the runtime and the memory, because those does not exist. Then once we have manually input all of the codes into LeetCode and obtain all the data here, we generated a graph that performs in comparison between the total acceptance rate and between the without setting and with setting, where a detailed analysis we have put on our report. And lastly, for the next step of our project, we are planning to use the ones that has successfully passed. For example, these legal question has 100% pass rate. To see for our research question 2, are we able to using some informal settings or command constraints that we explicitly write down individually for each of the question, and see if we can generate a result that we can work with, or not necessarily work with, generate a result that is able to prove GPT is able to adhere to our settings, even though they are informal and essentially verbally. Then for our research question 3, we will see if we can convert these successfully passing generated code specifically for the default one, and see if ChatGPT is able to translate the Python 3 that it has previously generated to C++ or to Java, and using that to test on LeetCode and see if it's able to accept it. If so, have we got the similar performance in terms of runtime as well as memory? And that's what we are planning to do. Thank you.